Okay, so picture this. You're standing in the Sinai Peninsula. It's, sand, rugged mountains, the whole deal. When you think treasure out there, what's the first thing that comes to mind?
For most people, it's ancient history. Gold, pharaohs' tombs, that sort of thing.
Right. Or maybe those famous turquoise mines. But today we're not talking about anything shiny. We're digging into a different kind of buried fortune. It's gray, it's industrial, and it's worth, well, an estimated $300 million.
And this isn't just for decoration. This is the stuff that literally holds the modern world together. We're talking about manganese.
Manganese. I'll be honest, it sounds like something from a high school chemistry class I definitely zoned out in. But the more I looked into these reports, this new discovery, it's not just a geology story.
No, not at
It's
all.
a story about a potential economic boom and maybe a whole new industrial strategy.
It really is. The discovery we're diving into today involves these massive quantities of manganese ore, and that $300 million number is what grabs the headlines.
Yes.
But the real story, the much more interesting part, is what happens after it comes out of the ground.
Exactly. Because we've all seen this story before, haven't we? A country finds a resource, they dig it up, sell it for cheap, and the real wealth goes somewhere else.
The classic resource curse.
But the plan being laid out here seems different. It's about shifting from just, digging to actually building something
Yeah.
to complex industrialization.
Which is always easier said than done. But if they can pull it off, it's a total game changer.
Okay, so let's unpack this for everyone. I think we need to understand three main things. First, what even is manganese and why does the world need so much of it?
Mm-hmm.
Second, the math. How do we even get to a number like $300 million?
The valuation, yeah.
And third, and this is the big one, the strategy. How do you actually turn a pile of gray rocks into a modern industrial engine?
Let's start with the rock itself. Because for the average person, manganese is it's just another element on the periodic table.
Yeah, and the reports call it a mineral that heavy industry cannot function without.
Mm,
It's a huge claim. I mean, we build bridges out of steel, not manganese.
true, but here's the secret. Without manganese, that steel is, for all intents and purposes, kind of useless for anything heavy duty.
Really?
Think of steel like a cake recipe. You have your flour and sugar, that's your iron and carbon. But if you stop there, the cake might be too crumbly. It's brittle.
So manganese is the eggs, the thing that holds it all together.
It's more like the ingredient that makes it tough. When you add manganese into that molten mix, it creates this incredible property called work hardening.
Work hardening. What does that even mean?
It means the material, the steel, actually gets harder and tougher the more you beat on it.
Wait, hold on. So if you hit it, it fights back by getting stronger.
In a metallurgical sense, yeah. The energy from the impact actually rearranges the atoms at the surface to make it harder. It's why it is absolutely essential for things like railway tracks.
Oh, okay. That makes total sense.
Think about it. A train weighing thousands of tons, day in, day out. The constant friction, the impact. Normal steel would just wear down or crack. Manganese steel thrives on that punishment.
So it's the same principle for things like the jaws on those big rock crushers in a quarry.
Exactly. Or the teeth on an excavator's bucket. Or the big girders holding up a bridge that needs to flex and handle constant stress. It's all about resistance to shock, friction, and wear. It's the toughness secret sauce.
So it's the blue-collar hero of the periodic table, basically.
Mm-hmm.
But the reports also mention something a bit more modern, batteries.
And this is where the demand really starts to look interesting for the future. For, 100 years, manganese was all about steel. But now, with the EV revolution...
Of course. Everyone's trying to get away from cobalt.
Precisely. Cobalt is expensive, and the mining has a lot of ethical baggage, so the industry is looking hard at battery chemistries that use more manganese because it's everywhere, it's stable, and it's a lot cheaper.
You hear about NCM batteries, right?
Yeah.
Nickel, cobalt, manganese.
Yeah, and that M is becoming a bigger and bigger piece of that pie. They're even developing batteries with very little or no cobalt at all, relying much more heavily on manganese.
So Sinai isn't just sitting on an ingredient for old-school railroads. They're potentially sitting on a key component for the green energy transition.
Which means the market for this stuff isn't going anywhere. It's not a fad. As long as we build things and drive electric cars, the world will need manganese.
Okay, so the demand is solid. Now let's talk about what Sinai actually has. Because this isn't just like a minor find.
No, all the geological reports are pointing to a very serious deposit. And they're not just highlighting the quantity, but also the good quality of the ore.
Why does good quality matter so much? Can't you just refine whatever you dig up?
You can, but it all comes down to cost. In mining, the grade of the ore is everything. If you have low-grade ore, you have to spend a fortune on energy and processing to get the useful metal out.
So you're basically burning money just to get to the starting line.
Exactly. If you start with high-grade ore, your profit margins are healthier right from the beginning. And Sinai's indicators suggest they have ore that's good enough for large-scale, profitable production.
Right. Let's get to that $300 million headline. I want to do the back of the napkin math here just to see how real that number is.
It's actually a pretty straightforward calculation. The project sources are projecting an extraction volume of roughly 1 million tons over the project's life.
1 million tons.
Okay. And if you look at the global market price for manganese ore of this quality, it fluctuates, but it's generally in the range of $150 to $300 per ton.
So 1 million tons times, say, $150 gives you $150 million on the low end. And times $300, you get your big headline number, $300 million.
Correct. And remember, that's in U.S. dollars.
Which is a huge point in the local context.
Right.
For Egypt, in Egyptian pounds, we're talking about billions. That's a massive potential injection of revenue.
It absolutely is, but, and this is probably the most important but of this whole conversation, that $300 million is the value of the raw ore.
Ah.
That's the price you get if you just dig it up, load it onto a ship, and wave goodbye.
And this is where the story gets really interesting. Because historically, in Sinai, that's pretty much exactly what's happened, right?
Unfortunately, yes. There's a long history of mining in South Sinai, but many past projects were hampered by what economists call incomplete manufacturing chains.
Which is just a fancy way of saying, we do all the hard, dirty work and someone else makes all the real money.
That is the resource curse in a nutshell. You export your raw commodity for, say, 10 cents on the dollar. Another country processes it, turns it into a high-value alloy, and then sells it back to you or to the world market for $1.
You lose twice. You miss out on the profit, and you have to spend your foreign currency to buy back the finished goods.
Exactly. So the whole strategy outlined in these new plans is to finally break that cycle. The key phrase they use over and over is value added.
That's the holy grail here.
It is. The plan isn't just to open a mine. It's to build concentration and treatment units right there next to the extraction sites.
Okay, walk me through that. What does a concentration unit actually do?
Well, imagine the rock you dig up. Maybe only, say, 30 or 40% of it is actual manganese. The rest is just silica, dirt, other minerals junk.
Right.
If you ship all of that, you're literally paying to transport dirt across the ocean.
Which is not a great business model.
A terrible one. A concentration unit basically crushes, washes, and uses chemistry to separate the good stuff from the junk. So instead of shipping a product that's 30% pure, you're now shipping one that's 48% or 50% pure.
And suddenly your product is worth a lot more per ton.
A lot more. It commands a premium. But that's just step one. The full vision goes much, much further.
Okay.
The dream scenario described is the full chain. So step one is mining. Step two, concentration. Step three is building factories to smelt that concentrated ore into alloys.
Alloys. So this is where they make the, ferromanganese?
Yes, exactly. You take the concentrated manganese, you mix it with iron and carbon in a massive furnace, and you create the actual additive that steel mills buy.
So at that point, you're not selling a rock anymore.
No. You're selling a specialized, high-grade industrial product. It's the difference between a farmer selling wheat and a bakery selling artisanal bread. The value markup is huge.
And this connects back to what you said about imports.
It does. Egypt has a very large steel industry. Right now, they likely have to import a lot of these alloys. If this project gets going, that supply chain becomes domestic. The money stays home.
It sounds so logical when you lay it all out. So why hasn't this happened before? Why is now the moment?
Well, a few things. First, the geology. This specific discovery seems large enough to justify the massive capital investment. You don't build a billion-dollar factory complex for a tiny little mine. You need scale.
Right. The economics have to work.
And the location helps immensely. This isn't some remote, inaccessible place. This is Sinai.
You've got ports nearby on the Red Sea, and the Mediterranean is just through the Suez Canal.
Exactly. You can ship east to Asia, west to Europe with incredible efficiency. And the general infrastructure in Sinai roads, power grids, has been improving a lot. You need a staggering amount of electricity to run a smelter. That might not have been feasible 30 years ago.
Okay, this brings us to the ripple effect. We've talked about the money and the industrial strategy, but what does this mean for the people who actually live there?
This is where you see the real potential for transformation. When
Hmm.
you move from just extraction to full-on industrialization, you completely change the job market.
How so?
A simple mine needs, operators for heavy machinery, strong backs, but running a concentration plant in a smelter. Now you need chemical engineers, process technicians, quality control specialists, metallurgists.
You're creating skilled, higher-paying jobs,
Hmm.
a middle class.
You are. And all those people need places to live, schools for their kids, hospitals, shops. The industrial complex becomes an anchor for a whole new community ecosystem. It spurs development that benefits everyone, not just the company.
It could change Sinai from a place people just pass through to a place where people build careers and raise families.
That's the hope. But, and here's the reality check, it all hangs on one critical factor.
Let me guess. Proper execution.
Always. The source material is very clear on this. The success is entirely conditional on proper planning and follow-through.
Which sounds a bit like corporate speak for, please don't mess this up.
It is. It means you can't just build the mine and then hope someone else builds the factory. You can't let bureaucracy get in the way. You have to build the entire chain because the temptation to just dig and sell for that quick cash is always, always there.
It's the classic marshmallow test, isn't it? Do you eat the one marshmallow now, the raw, or do you wait 15 minutes and get two marshmallows later by building the industry first?
That's a perfect analogy, and global economic history is littered with countries that ate that first marshmallow. They took the quick money and left the real sustainable wealth on the table.
So it's a high-stakes game. But the payoff isn't just the $300 million. It's something bigger.
It's industrial sovereignty. It's putting the country in the driver's seat of its own supply chain. And in today's world, that kind of resilience is worth more than gold.
Okay, let's sum this all up. We started with a treasure hunt in the Sinai Desert. We found this massive deposit of manganese, the invisible ingredient that makes the modern world tough.
We ran the numbers. 1,000,000 tons, potentially $300 million. But we realized the real treasure isn't the rock itself, it's in the processing.
Right. The strategy is to stop being just a raw material supplier and to become a true industrial producer, building the whole chain from mine to alloy right there in Sinai.
Creating jobs, infrastructure, and turning a lucky geological find into a deliberate economic engine.
It's a fascinating plan. I can't stop thinking about that work hardening idea you mentioned earlier, how the steel gets stronger under stress.
It's an amazing property of the metal.
And maybe that's the perfect metaphor for this entire project. The economy is under pressure and needs to grow. But if this plan is executed properly, it's like adding manganese to the economy itself.
It toughens it, makes it more resilient to external shocks.
Exactly. It makes the whole system harder to break. The resource in the ground is just the potential. The execution, well, that's the hammer that forges it into something strong.
That's a powerful thought. The treasure's been found. Now comes the hard part, building the chest strong enough to hold it.